Hello, my name is Jake Chandler, and this is my BDAN 310 Capstone project. So basically, in this project, I've created and tested some predictive models using a couple of data sets that we'll be using. I got them down here. We're using body measurements and loan application. Here we go. Ignore the hair. Been wearing a hat all day, so I'm not gonna say it's my fault. Okay, but first things first. We're using these two data sets. The one we're going to use first is the body measurement. So we can go ahead and load this in by importing our data set. So we import that up to the console window as so. You see it goes right there, and you can see that there's 252 entries. Basically, this is 252 um, individuals, men, that we're looking at here, and what the goals of predict body fat percentage using all these other variables such as age, weight, height, density, neck, chest. It's pretty cool. You can use all these variables to determine body fat percentage of what we're looking for. So we're loading our data. Now we're going to run some lines of code. That way we can break down this data and find the value we're looking for. So first, let's run this line of code for our library. Um, it's actually already over here. Let's redo that so we can just kind of get a better idea. Um, so we run the line of code for the library. You can see it goes up to the environment window, 252 observations. Perfect. That's exactly what we need. Now we're going to build a linear regression model. Now this will help us predict body fat using all these variables. And there's a summary key that you can put in there, and that gives you the overall model performance pretty much for what we're looking for. So go ahead and copy that in there, and boom, we got our model right here. So pretty cool. And now we're going to build a decision tree. So we're getting crazy now. We're going to build a decision tree model to predict our body fat. And this is the code for the decision tree model. So run that in there, and boom, it gives us all these fancy, cool observations that we can look at to run this model. And as you can see here, it's given all these different variables. It's taken it and broken it down. Oops. Okay, I didn't mean to do that. But we're good though. We're good. Should be good. Um, so yeah, that's based on all these different variables, right? Um, Now we can use another method, which is the mean squared error, or MSE, if you want to be specific. And this can really tell us how close the predictions are to the actual values. So all these predictions, basically a lower mean square error means that it's a better model. So that's what we're looking for here. And we can run this code in here, and boom, there we go. So we got 1.53 around there for the linear regression, and for the decision tree, we got 3.1. So it just sums it all up right there. Pretty cool. Now we're gonna move on to our second data set, which is loan applications. So we're gonna go ahead and load this in here as well by importing our data set. So import that, see it go right up here. Now we got 272 entries this time, so we got a little bit more because we are working with 272 loan applicants pretty much. And whether or not they got approved, and we can predict that by looking at all these different variables such as gender, married, dependents, education, self-employed, and so on, all these different variables. So again, we'll do the same thing. We'll load the library data set in here, and there we go. It goes into this environment window up here. And now this basically just loads the data, converts the loan and result into a factor variable since it's categorical, which means it's either a yes or a no. Like there's no in between, right? And then we can move on to our logistic regression, which is what we're using to predict the loan approval based on all these different variables over here. So um, this is good for what you would call binary outcomes. And here we go. It loads it right up in here. Um, it looks a little bit different than the last data set, but that's expected because this isn't a linear regression, it's a logistic regression. So it's a bit different, right? Now, same thing as the last data set. We're now going to do a decision tree. So let's load our decision tree into there. Bam, bam, boom. And there we go. Uh, all these fancy numbers, awesome. Those are in here, and there's our decision tree. So again, it's pretty cool how you can run all this data and really find out what you're looking for. And so now we're going to just do an evaluation kind of thing. And basically we're just going to calculate the accuracy of it. You know, how accurate are these predictions? So higher accuracy means it's a better model. So the first one is 0.85. Second one's also around 0.85, but the first one is a little bit higher percentage. So that means our logistic model was higher this time. Whereas in our first data set, the linear regression, sorry, was it the linear regression that was more? We're gonna get to it real quick. We're gonna figure out which one was actually more. But anyways, you can compare them to and see which one is more accurate. And that's the goal of this, is to figure out which model is more accurate based on our data. So just kind of wrapping things up. As we work through this project, we got to test the models carefully so you can really interpret the results you're getting. Um, because if not, you might have to troubleshoot some data, as I have before at first. You might encounter some errors, which is typical. It happens all the time. Um, as Professor Cruz has told us and showed us that, accidents happen, errors happen every once in a while. But I feel confident these models work correctly and that you can meet all the requirements by doing just that. So yeah, pretty cool. Pretty cool. Yeah, that's it. That's about it. All I got for this video. So thank you so much for watching my project, and thank you for this semester. It's been great, and I hope you enjoyed the video. Have a good one.